Okie doke. Good morning and good afternoon, depending on where you are. I'm Joseph Kingham. I'm the chairperson, one of the chairperson of the Large Systems Working Group. Welcome to this, the first Large Systems session we've got for 2023's virtual GSE conference. This is session 9B. We've got the wonderful Mike Fitzgerald here to talk about the sequencing of Parmlib member events in an IPL process. As we go, please post your questions into the chat. We'll collate them, and if there's enough time at the end, we'll go through as many of those we can. So without further ado, Mike, over to you.
Thank you very much. Thanks, Joe. And thanks to everyone for attending. So I'll try and get straight into it. First of all, a little bit, Fit Software is based, you can see here, we're actually in Crosshaven in County Cork. The map tells you what Cork people think of the rest of Ireland, and indeed what the rest of Ireland think about Cork. So it's not an exit or Brexit. Some people, if you think of it that way, it's just a recognition of something special, Cork. For those of you that don't know Ireland too well, maybe a little, I'll relate it to some of the more famous TV shows and movies maybe. So the Derry Girls, Derry is up here on top, northwest. Even though I didn't watch it myself, Normal People, that was set in Sligo, that's here, and Trinity College in Dublin. The Young Offenders, which I really like, that's Cork City, with a much stronger Cork accent than me. Father Ted, the most famous of all TV shows probably in the UK. That's a fictitious island off the west coast, but the parochial hall actually is a farmhouse here in County Clare. The new famous movie, The Banshees of Inisherin, that's set actually out in the Aran Islands. So everyone's waiting on the Oscars for that. And then finally, I suppose, for all you Star Wars guys, you have Skellig Vihil or Skellig Michael. That's off the west coast of Kerry, where Luke Skywalker took some time out on the top. So that'll give you a little bit, somewhere where you can go on holidays when you're in Ireland. All right, let's get into what this is about today. So if you read the ZOS 2.5 initialization and tuning reference guides, you'll know that there are 84 members in the Parmlib. So we will not be going through 84 Parmlib members today. It would take a month. Instead, we'll be concentrating on the arcane member load, the load XX, which I discussed in a specific presentation for GSE about 2 years ago. So I'll be doing very little on that today, or far less, and we'll be getting more into the sequence, what happens afterwards. Forgotten functions of load XX that come into play before the IEA SIM and the IEA SIS settings. In fact, load XX can define which IE SIS parameters you will be accessing. And to show you that this time around, I'll give you some output from a virtual IPL showing the sequence, which is also used as a training tool. Not just, so that's our ICE product. It's easier to show that because it shows the expansion of the members. Well, that's how I've set it up. So you can see the test environment I've set up and how it expands out and the way we take the symbols, the parameters, etc., which is the exact same thing as what would happen in an IPL process. Below you get to see my name, not just in English, but in Irish or Gaelic, if you want to go for how we say Irish in Oscailga. So it's Micheál Mac Geralt, which means Michael, the son of Gerald. It's as simple as that. My background primarily as a systems and assembler programmer in the 1980s, but with the formation of Fit Software in the 90s, that switched mainly to product support and distribution in the MVS arena throughout EMA, specializing in operating system enhancement products and DBMS, particularly IMS DB2 and IT asset management. Our first product was SAE, standalone editor that became standalone environment. And for you, those of you that don't know anything about it, it's like a boot diskette with its own operating system to give you access independently to Z volumes and data sets. So it can IPL from the HMC console in under 7 seconds, and you can fix up any mess you or any other administrator made. Then later came ICE, the Integrity Controls Environment, and that not only controls and monitors the changes by administrators to your ZOS system libraries, but also the subsystems like RACF, CHES, TCP/IP, VTAM, etc., and allows you to do inspections to see the impact on the target system and sysplex of any changes you make. So before you shut that change request, you can see whether or not it has an impact, not just in the member, but throughout the sysplex. And you can run it in health checker, etc. So that's kind of the background and where I've come to with this particular session. Okay, so it's always good to know what I'm not going to be covering, as well as what we will be. So the outline of what we'll not be covering is here defined, as well as what we will be. Remember that HCD is used to define an IO configuration. The output from HCD is the IODF, the IO definition file. It's a vSIM linear dataset that contains both hardware and software IO information. The IODF dataset is named HLQ.IODF-XX. So high-level qualifier with an XX, where XX is the suffix named in the load member IODF statement. And we'll come to that. The IODF is used to define a network of hardware resources where these resources are generally available to both the ZOS operating system in the OSCP and the ZOS platform hardware in the IOCP, and any related SCON, FICON directors in the SWCP. We won't be getting into that today. The IPL initialization process begins when the system programmer or operator selects the load function at the HMC hardware management console, passing the load parameter. Not all disks are attached to a CPU, sorry, not all the disks that are attached to a CPU have loadable code on them. A disk that does is generally referred to as an IPLable disk, and more specifically in the ZOS world as the sysres volume. Our standalone product, standalone environment, can also be installed on an IPL track. Obviously, just not on a volume that contains the ZOS IPL track or IPL code. What that means is IPLable disks contain a bootstrap module at cylinder 0, track 0. At IPL, the bootstrap is loaded into storage at real address 0 and control is passed to it. The bootstrap then reads the IPL control program, IEA IPL 00, also known as IPL text, and passes control to it. This in turn starts the more complex task of loading the operating system and executing it. All right, that's the bit we don't really want to talk about. IEA sys 00 in particular, but we'll say IE sys XX is often considered the anchor member of sys1 Parmlib, but it's not. During system initialization, the NIP, the nucleus initialization program, first processes IE sys 00, that's correct, Parmlib member, to establish parameters, but not the end result, which may have, but because quite often that IEA sys 00 will have just a comment or a blank line in it. So from there, it determines from the suffixes that are specified on the sysparm statement in load XX, the really important member, or the sysparm parameter in the IE sim XX, or by an operator if it's entered at IPL time, which IE/SYS XX members are to be used. And in fact, it can be a concatenation. You just keep on going down and the parameters are taken and overwritten, basically. The sysparm parameter contains the response to the operator prompt for system parameters. Sysparm enables IPL to occur with virtually no operator intervention. But before IE/SYS, which can, as I said, be defined in load XX, comes after the load member, which is read by the IREMS and NIP. NIP, the Nucleus Initialization Program, its sole purpose is to create a system that once that is accomplished, it just goes away, it disappears. The one thing about NIP is it's intolerant to mistakes. So if there's any mistake in load, you just get a wait state. So it requires the parameters in the load member to be entered in specific columns, and they must be perfect. As we would say over here in the colloquialism, it must be spot on. You know, it can't be out even by one column. Always make sure you have a backup or an alternate load member, especially when IPLing a new system when changes are applied. As I said, you don't have an IPL without a load member. The search order for load XX, that's really important. The IRM, the IPL resource initialization modules, looks for load in a library called, first of all, SYS0 IPL parm. And if that data set does not exist, then it will look in SYS1 IPL parm, SYS2 IPL parm, etc., all the way up to SYS9. If it's not there, then it goes to SYS1 Parmlib in the IODF volume, and if not there, on the SYSRES volume. The first one of these libraries that it encounters, that's where the LOADX must reside. Otherwise, you're going to have a tough lesson in that you're going to enter a wait state. So you need to know where your load member is and your dataset naming conventions. Most people put it in SYS0 IPL parm, but for security reasons, sometimes in SYS1 IPL parm. But if it is in SYS1 IPL parm, then you cannot have a SYS0 IPL parm dataset. Right. The general IPL view. To successfully IPL ZOS, the system programmer needs to supply the device address of the IPL volume, the load XX member that contains pointers to all the system parameters or to several of the system parameters, the IODF dataset that contains the configuration information, and the device address of the IODF volume. After the bootstrap is loaded, the control is passed to IEA IPL00, which is the IPL text program. I kind of mentioned this already. And that prepares an environment suitable for starting the programs and modules that make up the operating system. So it clears storage to zeros before defining storage areas for the master scheduler. It locates the sys1.nucleus dataset on the SYSRES volume and loads a series of programs from it, which are known as these IREMs, IPL Resource Initialization Modules. Some of the more significant tasks performed by the IREMs, which we'll concentrate on, are that it reads the load parm information entered on the hardware console at the time the IPL command was executed. It searches the volume specified in the load parm member for the IODF dataset. IREM will first attempt to locate load XX in the search order we discussed in the previous slide. If a load XX member is found, and we'll always go on that basis, Then the open and read information therein, including the nucleus suffix, unless overwritten in load-parm, the master catalog name, and the suffix of the IE/SIS XX members, because it may not be just one to be used, that will be brought forward. Load the operating system's nucleus, where again the nucleus might be defined in there if it's not in the load-parm, entered at the operator console. And at the end of the IPL sequence, the PSA, the prefix save area, will replace the IEA IPL 00 at real storage location 0, where it will then stay. The last of the IRMs then loads the first part of the NIP, which starts up the communications with the NIP console defined in the IODF. During the NIP stage, the system might prompt the system programmer or operator to provide system parameters that control the operation moving forward of ZOS. The system will also issue informational messages about the stages of this initialization. IE/SIS NN, that famous member in Parmlib, contains parameters and pointers that control the direction of that the IPL will take. And the system programmer or operator may alter these parameters as necessary from the console. Right. Now we're getting to what does the load parameter look like? So this is what's given at your console. So the load parameter information is entered at the hardware console at the time the IPL command was executed. What must be there in the is the IODF volume address and the load XX. So these two here, they must be present. Can't progress otherwise. Also remember the load, or sorry, the load member must reside in the IODF volume or the IPL volume, as they are the only volumes known to NIP. So it's not going to find it anywhere else. So that whole search again that we discussed earlier, that's the process that's followed. The IMSI value, initialization message suppression indicator. This is the one that allows you to override the master catalog or the system parameter library. So your IE/SIS XX member and your master cat. The syscat and the sysNN, to do that, you really have to have it set to A or P. And that allows you to enter both, or you might just want to do one. So it depends on your in-house standards. If it's set to blank or a dot, then you're not allowed to do any of this. So that's the IMSI value. So that will, in the example I have it set to 0 because I want to show what's happening in the process itself in the IPL. But if, again, depending on standards, you will either have one of these letters in your load parm and then potentially an alternate nucleus. Okay, next guy. So this gives you an example of a load member. Well, it doesn't actually. This gives you an example of the syntax of a load member. And these are the primary here, the primary parameters. I've put the ones in green are probably the most important. A mentor of mine a long time ago called this an arcane member. And it's an adjective I've remembered ever since. I never knew what it meant at the time, but I looked it up. And I've looked it up again in the last couple of years. So it's a beautiful word for, he was a sysprog. He obviously took some time out, but it's something that requires secret knowledge to be understood. Or if you look it up in Google, it says the adjective understood by few, mysterious or secret. So I think it's a word system programmers should use a lot more, because I think it definitely will improve your salary scale by using these kind of words. So you get to see the parameters here. What's important is that all parameters start in. So if you look, sorry, if you look at this, like I said earlier, you have this comment here which shows you a grid, because everything is defined in a particular column. It's a little bit like assembler in that it's column 1 to 72, but that's about it. The column 1 is where the parameter must begin, whereas in assembler it would be a label in column 1, and your parameter comes in column 2 forward. Or it's a little bit like RPG as well. Like I say, use lots of grid lines because it's the only way you'll get the correct parameter or keyword in the correct spot. What else? You don't need all of these parameters, and you don't need them in this sequence. You put them in any way you want to, in fact. How you do it will depend on whether you define just one LPAR in the load member, or if you have multiple CPCs or multiple LPARs per CPC. And it really is an installation standard which way you do it. But if you do have multiple definitions, so in this case here, hardware name would be your CPC normally, will define more often than not for each of our LPARs some of this information here, and then we'll have to do what's called filtering. So I've done a little bit of that on the next. The organization of the load statement parameters, the primary focus should be that it's fairly easy to follow. So in the same way, if you have multiple LPARs defined, then you'll create a hierarchy like this so that it's easy to follow you. However, you can't have this indentation. Like I said, everything begins in column 1. So what it will mean instead is that you'll use a lot more commentary with the asterisks in column 1. On the right, like I said, on the right here, it illustrates the hierarchy. And what can I say? Not a whole lot really, but you'll find that by actually going to the next slide, we'll see how the filtering works. It's always easier when you take something like this. So here we're taking a real simple example. It's just 2 LPARs that are defined. You can see in the filtering here in the load member on the left, the first 7 parameters are common. So that's these guys here. And it's the same here. As we do our filtering, they'll pop up like that. What I want to say here, the hardware name PO2 taken from the hardware token. That's here. The member contents, we're taking load FC. So it's the FC piece that we're doing. You can see that up here as well. In our load parm, we've got the IODF volume, and then we've got FC, our load member. And this is our load member here, load FC. What else? It follows exactly the IPL products. And this, so you can see here, what's happened is, this is the common area, and the 2 different LPARs have different parmlibs, but we're taking the F005 because that's the one that we wanted. And therefore we have these 3 parmlibs coming out here in this piece. What comes later is stuff like the nucleus member and the sys1 parmlib. So the processing, we're actually going to see some of the processing, but the nuke 0n member and the sys1 nucleus, the MVS level, master catalog, IODF dataset, catalog parm members, the SIM, which is really important, and then the sys as well. This is the SIM statement. So again, this is fairly, everything I need to say is on the slide, to be quite honest with you. You'll often find multiple members for the symbol definitions. So here's the way it's defined. And this is showing 0102. The L means it's just listed on the console so that your operator can see that there are two symbol two symbol members with their definitions are going to pop up. Also, there are OS reserve symbols like sysclone, sysname, sysplex, etc. And the easiest way to find out what you have is just under SDSF or EJES and go in and type display symbols. And this is the type of thing that you'll get back. The sysparm. So this slide again, it's kind of self-explanatory. Take note of the caution piece that I have in there, where you should have a load member without a sysparm defined. Again, because if something goes wrong with your sys member, again, your IPL is going to stop. So it might be better to have a load member without the sysparm statement included. That way you can override or supply a sysparm member just by operator. Again, during the system initialization, NIP first processes the IE/sys 00. And like I said, that's normally a blank line or comments, but people do make it their primary sysparm. Then it determines from the suffixes in the load XX the sysparm parameters in IESIM XX, and there could be several of those. So again, we can see the same thing like we saw in the previous one, where you have potentially multiple sysparm members. And we'll look at a list of some of the extensive parameters within IESIS in some of the next slides. The syscat, all right, again, this is kind of self-explanatory. The syscat parameter is used to identify the master catalog in columns 20 to 63 up to 44 bytes long. So there's your DSN from 20 forward. Master catalog type, you would be using this when you've got multiple LPARs in your KEC or CPC. To denote sys percentage to sys1 conversion. So because SMS requires uniquely named data sets, you normally would not be able to access the system data sets for one system from another system. However, you might need to update one of the other systems sys1 data sets from a different system. It's instead of using SAE. So the sys percentage facility allows you to do this by permitting access to system data sets with alias names. The alias names have sys for the first 3 characters, followed by another character that is not 1. So for example, you might use sys A as in alphabet. You use the alias to first orient the search to the appropriate master catalog, which is then searched for the requested system data set. All right. Now, what I've put up here, this piece, this is an extract from our ICE Direct, which is a web-based application platform around our ICE product. And it's a ZOS resident web server within the product. But you get multiple things. So it's a nice GUI front end, makes it easy for people to just click and go and see things, what's happening, see the contents of the member. But what's nice here, and the reason I picked this particular piece is it shows you the sequence of what would happen. So we're starting with our load X, then it goes to the SIM, then the sys, another sys, another sys, another sys, and then we start going further, the SVC, the prog, etc. So the you use ISVCXX to define your, to take these. We've kind of covered these a little bit. So the The SVC, it's your own SVCs, which can be numbered from 200 to 255. During system initialization, the system reads the ISVC XX members and places any SVCs you specified in the SVC table. The prog X member, for me, it's primarily for the libraries that you want to authorize, but it contains the following option types: APF exit, which controls the use of exit and exit routines; the syslib, which allows for the definition of alternate data sets for the system defaults. So your sys1 link lib, miglib, CSS lib. The SIE AL NKE, SIE MIGE, and the LPA lib. What else? You use the IEA fix for specifying modules in the fixed LPA, and so on. Sorry, I've gone too far there. So the next bit is, again, what I've put in here is simply, I could have done it with a 3270, but I like the color simply because it highlights where these things are going. It all just shows us the multicolor that comes in. The LPA is obviously the LPA library to concatenate to sys1 LPA lib and to build your pageable LPA. The diag DXX controls the common storage tracking and GFS trace. The couplex, cross-system coupling facility, so lots of parameters, so authorized programs on MVS systems in multi-system environment can communicate with programs in other MVS systems. I'm not going to go through every one of them, but you can read up what every one of them does in the tuning and initialization guide. Anything of importance there? Let me see. Maybe the dev sub XX, that's the installation default for device support options. Maybe even a little bit that will be coming in under NIP. And clock NN, yeah, that's just time of day parameters where the control of the IBM sysplex timer is important for accurate sequencing and serialization, that side of stuff. Master JCL, master scheduler JCL, you can place the master scheduler JCL in MST JCL XX as an alternative to keeping it in the MST JCL module in sys1 link lib and having to assemble and relink it every time if you make changes. So that's an important one. The scheduler NN, so that's PPT, master trace table, and AB codes for automatic restarts. But in particular, that's where your programs to be included in the PPT are defined. And then the BPX PRM, that's another one, contains the parameters that control the ZOX Unix system services, environment, and file systems. So all of these things are progressed down along. And we can see here some more. And then down at the bottom, we've got, well, basically subsystems or other starter tasks that we want to put in place. So that can be anything like your VTEM, TCP/IP, your TCP/IP data nodes, all the rest of it. All of these things will then be, in our case, inspected to see what happens. Okay, so quick look, let me just see. We're doing okay on time. All right, now when it comes to IE/sys, you have what's called directors and parameters. So if we look at the, I call it Varnund, but Varnund, that simply asks the system, the warn when finding an undefined system parameter rather than prompt for new system parameters. So some of these are just put in. They're a straight parameter that tells the system what to do. Whereas the others are directors, and these lead us to other Parmlib members. So if we look at the SSN, that completes the name of the Parmlib member SSN, which contains the information to be used in identifying subsystems that are initialized. The SCH, and all of these ones in red are security as well. I like they're security based, so there's something you need to consider when you're making changes in these areas, or who should be making changes. The SCH specifies a Parmlib member, the schedule SCHEDXX, from which the master schedule obtains its parameters. And the member centralizes control over the size of the master trace tables, the really important program properties table, so PPT, so that's why that's important, and the completion codes that are eligible for automatic restart. Our SVC obviously completes the name of the Parmlib member, i.e. SVCXX, where we define our user SVCs. NIP processing places the SVCs in the SVC table. SMF, which is another one that should be where authorization to access is really important. It specifies the SMF PRM-XX member, which where SMF contains or obtains its parameters. So you really want to make sure that somebody doesn't turn off some of the SMF records, like when somebody is opening a particular data set, or when they're accessing particular RACF features or whatever. So whatever records are defined, or with those records that you want monitored and written out in your SMF data set. So this defines which of these SMF PRM members where those particular records that you choose are to be put. The LPA completes the list, or the name of one or more Parmlib members in IPL, LPA, LSTXX that contain names of data sets that are to be concatenated to sys1 LPA lib for building the pageable LPA, the fixed LPA, the modified LPA. And again, prog, we've mentioned this a tiny bit earlier. This completes the name of one or more Parmlib members that specify the format and contents of the APF authorized library list. Prog-XX can specify either static or dynamic APF list, and it contains statements that controls the use of installation exits and installation exit routines. You can use the prog-x instead of APF list member and instead of linked list to define the linked list concatenation. Any data set that you define in here, you need to make sure that it's pre-allocated. So people do it normally in their test system. They know there's a vendor coming in and they say they want something pre-allocated. It's not that important anymore because you can dynamically allocate things now. But in the old days when you had to do an IPL, but some people still have a habit of, because they want it defined as a static definition in case of a future IPL, they may put it in before they allocate the data set. And not a good idea, because if you forget to allocate it, somebody else can allocate it. Okay, so these are listing out the 84 members. Just thought you might be interested to see them all lined up one after the other. It's in the initialization and Unix reference. If you click on one of these, it'll take you straight to it on the IBM website. And to find out more about it, it's that old acronym RTFM, and you'll discover everything you need to discover on it. So what I've done is I've taken an example of a virtual IPL here. And I say it's virtual because this is the ICE product, but it takes the exact same flow as what happens in a real IPL. So you'll find that we find that people use this in particular, not just to verify that everything is going to be okay, both in their live system, because they might have to back out and they want to see, will it still come up, or in their future system that they're going to, but also in training their system programmers. So I've set it up here. So I've got display on, so it shows the actual contents of the member as well. So this is the top of the member, and you'll have bottom of member as well. I've just tried to keep it as short as possible. But for the IPL, we must give the IPL unit address. So that's up here, and then the load parm, where the load parm is made up of the IODF unit address. That's the 0883, and then your load X member XX, which here is X1, the IMSI value, which is blank or a dot, so there'll be nothing happening there, but we are giving an alternative nucleus, which is 1, so that'll be nuke 01. So that's it expanded out. I won't discuss this here. I'm using a VM definition. So we're going to be taking the VM user ID as defined here, ZOS23B. And then this is the flow of how things would happen. We can see that the target system is ZOS23B. We can see that SVC lib is actually found, so it does exist. Where it's allocated, the nucleus, it is found. Again, where it's allocated, all important. And then we start inspecting the IPL text. And here we can see this part of the information going forward. So what level it's on. Next piece, we're searching through the load XX member. Here is our load XX member. Then we'll do the filtering again, which we had earlier. What we can see is that we've got an IESIM X1. The IODF is here defined again, and the nucleus is 1. Syscat is here, and just various other bits and bobs that you might want to use. Moving forward, the next part of the process, we'll be searching for nuke 01 to ensure that it does exist. There it is. Thereafter, we'll determine our MVS level. In this case, we're running 2.3, not 2.5 or 4. Then we start searching for nuke 21 member, determining the master catalog, determining the IODF dataset. All of these things have to be there. If they're not, we're in trouble. Determining our master catalog, and then the Parmlib members. So these are defined here and allocated. So again, this is all okay. And like I said, this is the sequence that would follow in an IPL. The next part is our SIS member. So sorry, I should go back there a little bit. Oops. So we've got the SIM is X1, and that's gonna pass us our values. Here it is, SIM1, and here is our SIS definition for the LPAR we're dealing with. So it's got a SIS name, SIS clone, and within it, we're going to be using the SIS parm, i.e. SIS, WS, CM, and XB. So this tells us there's going to be at least 3 other members that we'll be taking values from. And here it is when we process that out and do our filtering again, we can see what the sim processing comes out with. So these are the various symbols, and we can see here our sysparm. On to the next one. So what does this all mean? So what I've done is, because we take IE_sys00, it does exist, so we have to take it into account. This is the top of that member and the bottom of that member. And then we would search through each of those other 3 members that we saw. So the WS, the CM, and the XB. And again, I haven't put in because it would take too long and take up too much room. But again, we have a top of member, bottom of member with all the various parameters that are defined within it. And then we check the data sets defined in there to make sure that they're all there, which they are, page data sets, etc. And then it goes on, the non-VIO. You can see some of it here. Basically, what the last member here in XB had the VIO as a non-VIO data set. So this one doesn't count. And then if I take it forward, when we take that concatenation, if you can call it that, but what's really happening is it's taking the parameters, and if the next parameter in that concatenation is different, then it overrides the prior one. So we can see here which parameters were taken. It's normally IE_sys00, but if there's an override of any sort, then we'll see what that is and where it is in that concatenation process. And that tells us which of these parameters moving forward in IE_sys will be used. So rather than you thinking what might be used, this will tell you exactly what will be used. So it's good for teaching your system programmers what's going to happen. Plus, if anything goes wrong, you can see from this, you can access these reports and see what's gone wrong in your IPL process. Another piece that's nice, which I've put in, is I go through all of the members, and we'll see if there's, in this summary report, if there's a problem. Now, what I did was I just looked at these. One has a warning, another has a warning. This one has an error. So E for error, obviously. In this particular one, in the prog member, it was an integrity issue. So it's just, in fact, this is a notice, not a warning. And it's just letting you know that you have it defined inside in your prog member, but it's never been allocated. And in most sites, that's a no-no for auditors. So you need to fix it up. In this one, it's in fact unbalanced comment. So the problem is when you've got an unbalanced comment, you open a comment somewhere, and it's a case of when does that comment finish? So if you've got a comment later in the member, it's at that later point, and the interim parameters will be lost. So again, you need to fix something like this up. So it's found what it thinks are parameters within a comment area. So it's letting you know you need to check this out, whether or not it's correct or not. And in this one, it's in a command member. So the command is where you normally give your start commands for particular started tasks or subsystems. And so it runs the JCL to see if in fact it's valid or not. And in this case, it found a JCL error in one of the procedures in the BPX test. So again, you can click on these and it will bring you to it directly. I've only put these in here on the right hand side, but this one, in this particular case, it had multiple data sets that were defined. All right, so from there, it just goes forward again, and we have the IEA SVC. In this case, I don't have anything defined. It's just a comment in here. And then I go to my prog AB member, and there's multiple prog members as we saw, and this is just adding DS names and the volume it's on, so authorizing these particular libraries. Okay, so what else happens? Well, what you need to be aware of. Okay, so we saw in the earlier GUI type screens the lots of other things that take place. We won't go through each and every one, but some of the other integrity areas you should worry about, and your mainframe auditors definitely will be the APF member, i.e. APFXX. It's still there, so people do still use it. Probably the most important aspect of this one is that you ensure any data set defined in it pre-exists, which I've touched on a few times. Do not define it in advance of allocation, as somebody else might otherwise allocate and use programs of their own. Today, most authorized libraries are defined in the prog.xx members. You're also not limited by the number. In the prog.xx, you can define as many authorized libraries as you want, whereas in the APF, you're restricted. The linked list XX defines the linked list, but again, you can define some within prog.xx. The LPA list member to define the LPA. The PPT is defined in the SCHEDXX member, where any PSW key close to or equal to 0 needs special attention. Also, whether it can or cannot be cancelled, so that's important in there. Some SVCs are part of the core nucleus. Others will be called by applications or products when required. For exits, actually, we have a piece of software called the Exit Explorer from Trident Software, which will determine up to 500 exit points, as no one administrator will cover all the subsystems. So you'll have system progs that might do the SVC exits, etc. But anything to do with SMS will be done by the storage admin. RACF exits, if they're there, will be done by the security guys, etc., etc. So it's highly unlikely any one person will be able to cover all, unless it's a very small site where you've got 2-3 sysprogs that do everything. But otherwise, you will need to find these type of things out and to control them. Where do we go to from here? Again, I'm not going to do much on the ICE product, but it's just kind of to show you the type of things. There's multiple areas, and because security is important, one of the things is just to see what's happening, not just in the LPAR you're in, but for these shared data sets. And these data sets are shared. In fact, they're in all 5 LPARs. So we can see here, we just call it 01 here. And then this is the actual system name on top. Which release of ZOS it is, the IPL unit where it resides, all of, lots of little information. And then down here we can see what type of security level it is. So user, local, below the line, pageable, modifiable, fixed, APF, and protected. That's defined here. And then you can see where it is. Now, the same thing can be set up so that you'll see what's within a sysplex, what's across multiple sysplexes, what's across multiple sites, in fact, because all the information can be fed in and we can view it through the ICE web browser. This is, and we're way on time, so this, well, maybe not. This just gives you an overview of this IPL. It gives you a little bit more detail, picture of what we've been viewing up to now. The HMC might be known by some new appliance name in the future, we'll have to see. But the IODFIOCP, which is up here, will give us all devices and LPAR names. The IODF OSCP that's used, sorry, that's down here, gives you the OS system identifier and the devices assigned to that LPAR. To successfully IPL ZOS, the system programmer needs to supply the following info, which we've discussed a few times: the device address of the IPL volume, the load.xx member, the IODF dataset that contains the configuration, and the device address of the IODF volume. The RIM or IRIM is your IPL resource initialization module. IODF is an IO definition file. An IOCP is an IO configuration program, which in the old days used to be a macro. And the OSCP is your operating system control program. And that's kind of it. There's a lot more besides, but trying to keep it to an hour, I kind of left a lot of stuff out. What else do you need to know? Well, like I said, we're based in Crosshaven. We also have offices with UBS Heiner in northern Germany. You can catch, if you have any questions later that we don't get to now, you can send it to me here. I haven't put in, because this is published, I haven't put in my email address, just send it to info instead. That's our telephone number. You can find out a little bit on these products if you want to. And that's about it, I think. So I'll see if there's any questions.
Yeah, thanks,
Thank
Mike.
you.
That was fantastic. It was really good. Really enjoyed that. We have two questions here. One from Tim, which is, what is the product you use to simulate the IPL?
Okay, so it's a product called ICE, the Integrity Controls Environment, and it's used for change management and impact analysis. So ensuring no change request is closed at a line or member level until inspection is completed across the member, the LPAR, and the Sysplex. And most people use it, they run it on the live system so that you don't do a shutdown. I've had cases where people ring me or ring the office and say, you know, your product says that we've got an error here, but our SE, let me say it that way. Our SE tells us, no problem, go ahead. A bit like the Titanic, no issues with the iceberg. But sure enough, when they re-IPL, it doesn't work because it goes into a wait state or whatever. So it's there to make sure that you do it on the live system before you do a shutdown, and you do it on the target system before you bother even doing an IPL. And also, when you do, it's a good idea to do it before you do a shutdown, because it tells you everything that's different between your definitions and your dynamic changes. Because when you do go to the target, the new target system, you might want to bring up LPA areas, reinitialize them, or linked list or whatever, because otherwise you'll get somebody ringing you saying things are going a bit slowly here or not working at all. And in today's world, especially in the last couple of years, we've had sales because you can't do mentoring anymore. Sysprogs aren't sitting beside each other. So you'll find that this allows your trainee Sysprog to actually go in there and discover what the hell he's changed before he signs off and says, yeah, I've done exactly what you told me. He can now go back and say, I've done what you told me, but it's causing an error in our backup residency, because you don't want to do it just in your live systems. You also want to check it against your backup, where you may or may not have shared members. So that type of thing. So that's the ICE product, Integrity Control. It used to be known as Image Focus. Now it's called Integrity Controls Environment.
Great, thank you. I'm thinking that answered Tim's question. Otherwise, he'll put something else in the chat. We have another one from Bertus, which is, do the assembler message prefixes have any significance?
Do the what prefixes?
The assembler message prefixes.
The assembler message.
Prefixes.
In which member? Where is he?
doesn't say that. I don't know if Bertis can. Oh, IFO. I mean, I could.
Oh, sorry. Oh, sorry. This is in the product. I was thinking of an IPL. Sorry. Okay. So if we go back, yeah, all our they don't mean it. They are only actually of relevance in our product. So these type of things here, these are all informational. So certain of these mean, you know, this is just an information message. You'll get, and then at the end, you'll get ones which will outline all your notices, warnings, and errors. Now, because people also, in fact, this is not just an inspection process. The ICE product can run under IBM Health Checker. So people actually have this running on all their LPARs. They'll roll it out to all their LPARs, and these messages come back to the health checker in the same way that they come back to our inspection process or to the ICE direct web server. And it means that you know, your health checker will only normally be interested in your notice, errors, and warnings. But some people have, in fact, they know that, you know, if we take something simple like the authorized library being defined, they're saying, well, it's in our test, but we're going to be allocating it in a couple of days. So in the meantime, make that warning a notice message. And you can do that type of thing. We can say, using this particular piece here, searching for IE says. So we'll give a piece of text plus that. We want to change that I to an N or whatever. In the other case, it would in fact be a, I'm looking for, where did I put that? No, it's a bit forward, isn't it? Here. So that warning, we would take IFO warning, unbalanced comment detected. So I can say a warning with a piece of the text unbalanced. I can say which member and say it's not relevant at the moment because we know it's unbalanced, but we want to keep those parameters within a comment area because we might want to reuse them in the future. So they know it's unbalanced, but they want to keep it that way. So these messages are ICE image focus messages, which can then be used in health check, or we can change them in our inspection process so that somebody doesn't go back to their manager every day. It's showing up in the health checker as a warning or an error every single time, even though we know it is there, but we don't want it registering as a warning. So that's part of the reason behind those.
Okay, is that okay for you, Bertus? Yeah. All right. Okay, so he says, yes, IFO was for old F assembler, and so he was confused.
All right, okay, all right.
Okay, so we don't have any other questions, so I've just got the link here for the feedback. If everyone could please go to this link and give us the feedback, because that's what we need for this conference, please. And just leaves me to thank you, Mike, for that.
Yeah, no problem, really anytime.
Okay, thank you all for attending and enjoy the rest of the conference.
Thanks a lot. Have a great day. All the best. Thanks, Angie.
Thank you.
Bye now.
Thanks, Mike. Bye.